Hello, hello. We are back again with the antenna project. Let's see if I can get something pulled up here. Oh, nice. SolidWorks decided to crash, so give me 1 second. So as the title suggests, we are attempting to submit this project. Well, this project has been submitted to Opensauce 2025, which, if you don't know, is a conglomeration of makers and creators, a lot of YouTubers, and that takes place in San Francisco, put on by William Osman, which is an excellent channel to watch if you like nerdy, cool stuff. Well, it used to be. Now it's just kind of like a lifestyle vlog, I guess. But it's still fun. So last year I went and I brought a Battle Buttons, which was a timer system for combat robots. And this year I wanted to go again, and I wanted to use the satellite project that we're working on, the satellite tracker antenna. And what happened is I had to get my eyes operated on right in the middle of the progress of this, and I had to do a bunch of stuff kind of off camera here and go ahead and submit the project about halfway done, with the hopes that they would see the potential and give me a little bit more time to finish it off. Well, I didn't hear back from them for quite a while, and then Friday I got an email that said, we are really interested in your project, but we need to see a little bit more progress, which is fair. So I have printed the pedestal here that you see, and then the top knuckle, and I went ahead and mounted the motor. And with those things, I can make the antenna move in azimuth, right? Which is the axis that is parallel with the ground, perpendicular to the ground. I don't know. Anyway, so that works pretty well, and I am working on, so I got those tolerances like perfect. The two components that make that up are this knuckle here and the pedestal right there, and all we need to work on now is the elevation axis, which is going to move the dish up and down. And in doing that, I've also made a little bit more progress on the reflector, the sub-reflector, the main feed, some of those kind of components. Oh, the quadrupod, that's a big deal. So I wanted to submit a more complete vision, right, to SolidWorks, to Opensauce staff. And so I had to get a little bit of work done off stream. I don't know if I streamed this. I don't think I did. Anyway, so basically we're gonna try to print this. See, the thing is, it's really only okay. So the goal for tonight is to start printing some parts for the elevation axis, and then if I can, tomorrow I'm going to spend the entire day on this. I'm going to try to build a little mini web app and control elevation and azimuth, shoot a little video, add that to my email and send it back to Opensauce. Financially, after having my eyes worked on, I got put on short-term disability because I still can't see very well, And so I don't know if it makes sense to go on this trip, but gonna try anyway. I can always say no, but I think it's important to do enjoyable things even in times where it doesn't make sense. These opportunities are not going to be around forever, so we'll see what happens. I know that San Francisco last year, honestly, it changed my life. I pushed really hard to overcome a bunch of fears that I had about traveling alone with my kids and traveling in general, staying in places I've never been, making plans, spending money, and I was able to pull that off, and that with that confidence, it led to my participation in the Battle of the Builders, and that was just truly an amazing experience as well. So altogether, 2024 was filled with pushing myself beyond what I thought was capable, and I believe that my submission to 2025 Opensauce is going to do the same thing. I had to learn a lot about a lot to make my battle buttons work, and I've learned even more since then, so I'm really excited about it. With that being said, I will do my best to make this project feasible for Opensauce, but even if it doesn't happen, I'm going to finish this because I really want this antenna. That's the whole reason that I put this together. I want to be able to put this antenna on my desk. I want it to make the noises that it's supposed to make. I want it to point at the things it's supposed to, and I want it to move like the big boys do. So, man, I've been out of work for so long, I forgot how these things look. But hopefully, I'm praying that I'll regain some of the vision in my right eye that I lost after that surgery, and things will be kind of back to normal. But I'm gonna try to make the most of it, whatever happens. So I do have every electronic component to build this. The only thing that I'm missing is the physical assembly itself. So let's just jump into it. We're looking at, let's look at this assembly. I don't know if I streamed any of this. Honestly, I don't think I did because I was rushing this out blind in one eye while I was in the early stages of recovery. So what I've done here is I've split this into two parts so that we can print it without any supports. On the top side, on the bottom, it prints flat against the bed, and it has a nice base and mount for that motor. So this is really a good joint here. There's backlash, but it's all in the gear train of the motor. I'm never going to be able to get that out. Or at least I think it is. But it's not in my gear to... It's not in my ring and spur gear. So let's see if I can make this move without causing a dead short. One of the first things we need to do before I forget, unfortunately this can't have 360 degrees of rotation. Okay, let's see if we can do this. Pretty freaking cool, right? It moves really quick. That's on 9 volts. We're obviously not going to move it that fast. But this can't have 360 degrees of rotation or it will rip the wires out. So we have to go in here, will interrupt the travel of that ring gear, well, of the azimuth axis. And what that'll do is let us home against an in stop, essentially. We'll read that the encoder has stopped spinning while we're still commanding it. We'll mark that as 0, and then from that position we'll know how far to spin. And that way we don't need any limit switches or anything. So what makes the most sense? Probably this guy right here. All we're gonna do is frustrate the motor just enough that it quits trying. So there was a lot of thought process that went into this. Let's talk about that for a second. Okay, so you've got this flat plate here, and what that is going to attempt to do is prevent the little gear that's on our azimuth motor from falling off. So the way that the azimuth axis is, this gear presses on from the underside, and I fear that as it vibrates and moves around, it's gonna just try to slip down, because there is no way to hold it to that shaft. Like a little set screw or anything is just ridiculous at this scale. So what we've done here is pretty much give it a ledge to ride against, and I greased it up real good. So, oops, give me that back. That gear rides along the face. It's supported from falling down, and then just to support that ledge, I've made it come up at a taper so that there's no support, because this is designed to be easily 3D printed, and support material is not easily 3D printable. So then once again, we've got this channel and the 2 supporting sides, and what that's gonna do for us is essentially it locks our axes together, or locks our 2 components together, so that there is an inner and an outer constraint on this rotation. And then you'll see this strip around here that interacts with some set screws that go on the side. Let's see. And those set screws, I think they look nice, especially for what this is, but they just ride in that gear, and that prevents the entire axis from pulling out the top. And once again, they are at an angle so that they are tapered, so that they print without support material. And the weight of the axis rides on this face, and then the bottom channel face that is filled with grease. And as it moves around, it will these teeth hopefully act like a grease pump, allowing the grease to like slip up and move. And in one way, it's supposed to slow it down and make the movement more fluid and less jerky, but it also should kind of like re-pump the grease as it's moving. So now that we've got that tooth in our assembly that will prevent this gear from rolling all the way around, where'd he go? So it's gonna come over here, it's gonna hit that tooth, this guy right here. Let's see if we can snag him. It's going to hit that tooth. It's going to stop. We'll be able to read it because the encoder will have stopped spinning, and that's good stuff. So we needed to do that. The next thing we need to do is we need to just bite the bullet and decide how we're going to connect this knuckle to this knuckle. So the problem with printing this part is that this circle is not going to be round, right? When you print it vertically like this, it's going to be a bunch of horizontal layers. And so if you try to put a bushing or something in there, it's really not going to spin well. So the idea I had was to insert a bushing into it. So let's talk about that real quick. So the distance there is 0.35. Let's see what we can do. Okay, we'll get a center rotation right here. We'll call that 0.35, which we want a little bit of clearance on that. It was so funny, I printed the parts and they didn't fit together, so I was really discouraged, and then I moved away from the project for a little bit and came back, and they had cooled down and they fit together perfectly. And in that moment I realized firsthand that thermal expansion was real. Okay, so this is gonna come up like this. I want it to have a bearing face here and then come down like this way, this way, this way, this way. I want this the same height as this guy. I want this bearing face to be underneath is good. And then that is 1 inch diameter, 1.09. 1. Should we just use we could use our same hardware. I have quite a bit of it. Yes, I do. So let's get some dimensiones here. So we're do this as 0.175. The inside of this, we should have 5/8 plus 0.025. The depth of that part, we could have it go all the way up to that other part, but we don't want to because we have a connector in here. So in actuality, we do have a set dimension that we want this to be. So let's just take a little sketchy here. And we would really like that to be 0.75, but we called it 0.625, which is good, right? So what are we doing here? So that's the distance there. That's that distance. Okay, I guess we only want the thickness. Holy crap, what's wrong here? We want the we want our bushing to be the thickness of this face, maybe a tiny bit more. It's 0.8. Let's just make it 125. And this actually goes right here. And then this is just something fun. So, give me 1 second. My robot vacuum just came in my room. Never mind. It found its way out. Okay, so we'll do a revolve here. And we're going to call this elevation bushing. We'll add the elevation bushing. Right there. And we can set its right plane and this thing's front plane parallel. And then we can take one of these bushings and mirror it across. Then we can take a look at our antenna again, and we should have okay, so we've got our bushings in there. It looks okay, but in reality, I think that those go all the way out to the edge here, and that radius is 1 point. Is 2. That diameter is 2 inches. So let's edit that. So that would be taking this, and we give this an angle. Let's do it off this face here. 45, does that look cool? And this would come all the way out here, which would be just under 2 inches. So then we pop back over to our main assembly, and that looks a lot better. So, but it could be bigger. Let's just go the full 2. Give me 1 sec. Okay, so our bushing is actually, in reality, it's a giant bearing. It's crazy how big it is. So we're going to come up here and on the real deal, this thing has these little gussets all the way around it. So we're going to cut away all the material that is not that gusset. And we'll just convert these two. And we'll go ahead, do a circular pattern on that. Oh, I talked about this last time, but I hate how SolidWorks just cannot infer the parameters for a circular pattern. I wish it was smarter. 12? Does 12 look cool? How about 16? 16 too much. 16's too much. So we've got 12 of those. You know, there's multiple ways to do this. We could have cut it from the... Ooh, we might have to. We could have cut one and then patterned the cut, but what's going on here? Maybe we do just need to cut one and pattern the cut, or we can go in here and power trim the entities. I'm probably missing a step. These scallops that I'm doing right now are all in the name of aesthetics, but if you have watched any of my other streams, you'll know that aesthetics are almost paramount in projects for me. If it doesn't look cool, who cares what it does? Why can't I use that vertex? Oh, if I turn on the sketch, I can use that vertex. Yeah, buddy. Okay, so check this out. Whoever you are that just dropped off, you just missed the cool part. Boom, look how cool that looks. Oh, balls. What do we do about that? I think we cheese it. I think we just cut the part. Let's just cut the part because we are running out of time and who's gonna care? You know what? It actually might make sense contextually too. The way that it's built here. Probably not. It probably doesn't make sense in the real world, but I don't care at this point. A lot of this is not going to make a lot of sense. How bad? You know what? I know it's more work, but the more I'm thinking about this, the whole point is like scale accuracy, right? And making it look cool, and that just doesn't look cool to me. I'm sorry. I lied. I do care. So what we're gonna do, we're gonna go back into this part because What the heck even is this? All it is to fill the top. And yeah, we're just gonna cut that off. I built this part so bad and I apologize, but it is 2 parts in one assembly. I'm so sorry. Sorry, it's 2 parts within 1 part. Ugh, and even with that, we're still not tall enough. So what do we need to do? We need to bump up. So we have all this nonsense. That's not tall enough? Is that really what our problem is? Let's see how badly we screw up the assembly doing that. Okay. Boom, boom, boom. These have an external reference, so... Oh yeah, but look at that. That looks so much better. Yeah, look at that. That looks sick. We're gonna raise it up even more, actually, because I want to uncut those pieces off. But what is wrong with our... This motor, I understand, needs to be concentric there. Boom. And I think we're all happy. So why is this motor not happy? Okay, and so everything's mated good, and we'll undo that cut because that's dumb. That's not the way to do things. And I didn't suppress those, did I? Deleted them. So we'll have to go back in and add those features back, but no biggie. Can we do that? We can. And then we can come and add that chamfer that we love so much. Okay, that doesn't look too bad. And over here, it looks pretty good, but we've got this interference with that. So let's just turn that dude down a little bit. That's gonna be a lot. It's a solution. Is it an elegant solution? Don't know. But I'm too tired. We got 30 minutes left. And then we're gonna have to print some parts because I need to move forward on this. I cannot procrastinate this any longer. Okay, so we should have this part fits within that part just a little bit. That's a lot of clearance. That's not exactly what I wanted to do. So let's oh, that hole's not even defined as anything. Nice. So 1.025. This guy should just be one. Yep, so that fits in there. That's cool. That's grand. Let's do some forward thinking here. So if we are rotating, we're going to have a piece that comes all the way through and interacts with that gear motor. And it's going to stick down into this piece. Just a hair. I don't see why these couldn't be like that, and this couldn't be like this, and the depth of this couldn't be like this. Seems fine. So then we'll press our arm piece down into this, and that will give us a essentially the same situation that we've got going on for the azimuth. So the arm will have these features. So this thing looks pretty good. I don't know if we need to do a lot more. Man, I am so tempted because of the way that I am to fillet the crap out of everything, but it just doesn't matter the way that you think it does, you know? So how thick did I make these guys? 0.06. So if I fillet them 0.015. Does that look better? Yeah, it does. Shoot! I don't want to do that. What about that? That won't work. I like fillets, so sue me. On your on your scale antenna, you can not fillet things if you want to. I miss work. It's crazy. I mean, I really don't. I really could see myself doing stuff like this all day long. But, I feel I have a responsibility to my project and my mission, and I feel like I am not present where I need to be, and that is that's what's driving me, like, not to take advantage of this time off, I guess, or like exploit it. I'm definitely getting a lot of things done that I've put off, but I'm ready to go back and be a contributing member again. Yeah, that looks pretty good. So let's turn our edges off again. Yeah, I like that. These should look like they're separate plates though, so we want to add a dumb little chamfer here. These are just like body lines. And what that's going to do is just add a degree of separation for the rest of the knuckle, so that it does look like it's a plate bolted on, you know. What happened here? So that's a smooth radius down here. Do I care a whole lot? I mean, why did I do it like that? Should I have just done... No, I'm not going to redo that. I don't have time for that. Okay. But this part... Let's check it out. This part should, yeah, it fits right into that one. It stops well before we start interfering with our connector here. And we're looking good. So let's turn off our visibility. And now is where we get into our, what's going to make this look super cool. So the bolts that I have, oh, of course this thing's not on axis. We didn't need that. That's cool. So to center that up in that frame, we can do that, and this will represent the head of the bolt. Actually, do I care about the head of the bolt right now? I do not. So I just need a .08, 0.075 clearance. Circular pattern that. We'll pick up our point. We'll entity our pattern. We have 12 of them. I want 12. Ugh. And of course, our pattern is not defined. Why? try our circular pattern again. Or perimeter. I can hear my kids screaming in the background. They're playing video games. One's on Roblox and one is on Minecraft. So I've been selling. Okay, dimension radius, dimension angular spacing, equal spacing. Oh my gosh. How do you fully define this crap? Come on, you son of a biscuit. Why is it freaking out? Midpoint, 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 diameter. I am selling some wheels on Facebook Marketplace. I listed them for $450. It's the price. I don't really care if I get $450. I would like to get at least $400. But when you ask me what the minimum is that I'm willing to buy, what is the least I am willing to accept? You know, I get a little peeved. I'm like, just shoot me an offer, you know, lowball it, something. You'd be surprised how many lowball offers I end up accepting just because people actually put a freaking offer. But when you say what's the lowest, it just starts the whole thing off on the wrong foot. But I'm more than willing to sell these wheels for much less than I have in them. Actually, if I'm being totally honest, a peek behind the curtain, I have nothing in these wheels. Literally zero. I stole them from my dad. And I'm selling them to pay for my eye surgery. And maybe a trip to Opensauce, whichever one comes first. Okay, so that looks pretty good. We want to transfer. How many of these holes actually? Dang it. I'm an idiot. I don't want to pattern this anymore. Not like that, at least. Because I don't want to put a bolt in every one of these holes. I just want some of these to look like bolts. So, do 4. 4 is good. And then we're gonna do we're gonna do some bolt dupes. Some dupe bolts. Fakers. 0.14. And the height of that is 0.07. And we don't want to merge it right away because we want to add a back chamfer. To really sell it that it's a bolt. We'll fill it, all of it. We will come in here, do an extrude cut, and we're gonna even make it the right size if I can get my little calipers in there, which I can't, so we're not gonna make it the right size. That doesn't look right. But we are going to black up the sketch. We're gonna do that as the depth. And I think that the 3D printing artifacts will take care of the rest. So then we will do a circular pattern of these bodies. Direction 1, boom. Bodies, boom. And we need 12. But then we're gonna skip the ones that are over the holes. Then we are going to select everything. We're going to insert features, combine, add, donezo. So we have fake bolts that will match our real bolts, but we don't need 12 bolts to hold these parts together. We just need the 4. But because I am the way that I am, I would much rather the bolt pattern be offset. So we're gonna, instead of this being parallel here, I'm gonna roll this down. So it's like that, and then I guess this line can just be parallel to the top plane. And that should put us with a nice a nice square 4-bolt pattern. So at any point we have 2 bolts, 2 actual bolts. So we're gonna steal the dimensions of the actual bolt threads from this part because it worked. Uh-oh, why are we angry here? What's mad about this? In this assembly, we're happy. That's cool. We come back over here in this assembly. Oh, I know it's probably not happy. That's cool. Is that cool? Okay. That's okay. Let's see. Is that the one that's mad? Uh-oh, I got some kind of SolidWorks error popped up, but I don't know where it is. Yeah, so this knuckle is looking sick. we're gonna add, oh, apparently we can't edit that. Something is crashing. Something in SolidWorks is crashing. Thank you, SolidWorks, we love you. Is there a dialogue box that I'm just not seeing? What in the world? I can't do anything. You gotta love it. Oh, there we go. Finally, thank you. Okay. What is so angry? Mate over defined. Understood. Give me 1 sec. We're gonna have to reboot the old SolidWorks. So while that happens, if you are just joining us, I am building a 177 scale satellite receiver antenna. So this is a ground station, but it's going to fit on my desk. It'll be about this big, and we're going to use real GPS data, real compass data, and real satellite positions. And as they pass overhead, the satellite will pick up our dish here will pick up the satellite's location and track it across the sky. That's the whole goal. I submitted this project to Opensauce 2025, and they wanted some more detail because it wasn't quite finished, and so we're trying to give that to them. I need to finish it tomorrow. So we're gonna get that done. So SolidWorks is back up. We've still got some errors. Let's suppress that. Oh, that was it. She was dissatisfied with the central mate there. The concentric mate. Why? Because of this mate? Apparently not. So crazy. You never know, you never know. Can we mate this to that without causing a problem? Apparently, no, that caused a problem as well. Okay. We've got a width mate on the reflector, and we're concentric with the right plane. Maybe that's what the problem is. Yeah, so it wasn't even the mates that it was highlighting. Love SolidWorks. All right, so here we are. Boom. Yes. So that looks so cool. And then it's gonna come down, and if we suppress, which one of these mates does that? Why doesn't it spin? I don't know. You guys want to see the actual model? Let's see. So here is, ooh, let's do a full frame. Here's the first, well, not the first, it's the first pedestal, but I was only printing the top section of it until I dialed in the geometry between these two components. Now, when I connect this battery up to this motor, it spins. And so obviously we can't have it spinning around forever. Let's see if we can get that like right down the barrel. That is a really smooth motion. It's really locked into place. There's like no play, but there is some backlash, and I'm not sure exactly where it is. I don't believe that it's my little spur gear up there and it's interfacing with the ring gear. There is no backlash between my spur and ring gear. That's a fact. But there may be some backlash from the spur gear to the gear box. So that could be what I'm talking about. Is this D-shaped shaft to this gear here may have some play in it. So we can try to dial that in a little bit more. But on this first prototype, I did not add a stop. So there's no way to home the antenna. So the very first thing that I did on stream tonight was remove a tooth. So we'll drive the antenna completely to where it stops. We'll be able to read that it stopped because the encoder will stop spinning. And then from that position, we can drive out a known amount of degrees. So we should have the ability. I don't understand why this doesn't rotate. Does it want me to drive the little gear? Oh, the little gear has been... Gotcha. Anyway, we don't need to do that right now. What we need to do is poke a hole in this. So what we've... Oh, we were trying to steal the geometry from this when SolidWorks crashed on me. We want the exact diameter of this hole because that is that hole worked perfectly for the set screws that I used. So it was a custom diameter that I came up with. I don't have a water bottle over here. Which was just 1.5 millimeters. How original. We'll hop back over to this sub-assembly here. And we're gonna edit this part. We will... Oh, should we just use Hole Wizard? People get so mad. I'm people. When you extrude cut a hole. But Hole Wizard is kind of... It can be finicky. Where is Hole Wizard? I've lost him. Oh, features. There we go. Hole Wizard. Oh, sweet. It picked up the exact geometry of our other hole. Except we don't want that. We just want a dowel hole. Just call it 1.5. We could go back to our positions. That one's defined. Do we want to circular pattern this? We can circular pattern it. No, we won't. We're just gonna do points that are defined by these points. So just a moment ago, we made some fake bolt heads. so they'll blend in with our real bolts. And then this is going to be the area that we fill with grease, because that'll be our rotation. So that's what we're going to do next. We need to make a plug on the side of this part here, so we can just, oops, we're not hole wizarding that. We're going to just extrude cut all the way through this part here. And you can start to see what my plan is. So it looks like we need to make that hole in this part no bigger than 1.25. It's 1.3. No, that's fine. So no, we do need to make it a little bit bigger because this is a clearance for the next part that's coming. I might need to look at my reference photo here in a second. Pull that up real quick, actually. I don't know if I can share that with you right away. Oof, my air conditioner was not working last night. And now it's working too well, so give me a second, I need to turn that down. Okay, so SDO2 antenna. There we go. That is the antenna that I'm trying to copy. I'm trying to copy a Datron antenna. Solar. Okay. Some of this stuff is good to look at. Some of it is dumb. Okay, so I hate the way that Bing Images works, by the way. There's a lot going on the side of the antenna. I'm gonna bring that up. Just a moment here. We're going to add a source, an image, bear with me just a couple more seconds. Boom, boom. Boom. Beautiful. Okay. Can you see that? Can you guys see that? That's what we're trying to build. Yes, you can see that. You should be able to see that. So we've got our cool knuckle going on now on top. Let's see. The knuckle of the antenna kind of matches, right? Now we need to connect it to that shaft in the gear motor. And the idea that I had, how thick is this plate? Oh shoot, it's a 1/4 inch. We don't need it to be that crazy. But the idea that I had was essentially like a plug that bolted to the side plate here, and it passed through. This will be the actual bearing surface, and this will be a clearance, and then that plug, as we drive it onto this face, will interface with that shaft. So let's just start building that plug. We're going to start with a new, we're going to start with a new part. We'll do a, it's going to be a revolve. And the full depth of it is really going to be just about 1.14. Let's go 1.125. Okay, and then the first section of it is just going to be whatever interacts with that shaft. Then whatever passes through our bushing, then what's going to come down across our bushing into our channel and out to our main frame, and this all makes sense in just a second. So let's grab this diameter, which is 0.65. We can make this 0.65. The depth from this to the top surface is 0.53. We can make that 0.525 minus 0.015. The depth of our channel here is 0.25. So we can make that 0.25 plus 0.025. Come on, baby girl, don't do this to me. The diameter of our part here is 1.25. So we can make that and then we can make this point, and this can be arbitrary as well. Oh, 0.1875 was perfect. We need the diameter of this, which is 1. And That's about as good as we can do right now. So we'll go ahead and make this 60 degrees. Oh, the depth. How far in do we need this to be? At least 0.75 from the outer surface here. And I don't like the way that looks. Okay, let's revolve. Beautiful. Oh, what are we going to call this? This is the elevation drive interface. I used to have the most fun naming parts when I used to work as a designer. I would name crap so bizarre, but it would be so accurate, and so nobody would ever change it. Oh, let's look at our reference again. That really looks a lot thicker. This does. I don't know. Maybe it doesn't need to be. Does it look longer? It could be longer. We'll see. But this is going to need to interface with the reflector's top plane, I think. And then they need to be concentric. So I know we've got a bit of an interference there, but if we take a cross section of this, and I did all of my maths right. Oh yeah, buddy, look at that. It's almost like I know what I'm doing. Those tolerances are a little loose. Maybe. I forgot what I did on the tolerances for the pedestal to the knuckle, but essentially this surface here and this surface here should be almost in contact, and I don't know what the difference between those is. It's 0.0125. We should do a test print, and we can do that real quick. So we can actually print this whole part. Oh no, did I make a mistake? I want it to print without supports, but in order for it to go within the other part, no, can't do that. I'm thinking, what can we do? Man, do we just print it with supports? That sucks. A whole shelf of supports. Either we have the supports on the back side or the supports on the front side. What do you think? I hate support material. I hate designing stuff that has support material. I hate making that requirement. This is gonna bug me if I don't do this real quick. mean, it's not the end of the world to print with supports for sure. I just didn't want to. Do we care if this part goes with any other part at all? Does that give us an advantage? I mean, it makes it super simple to assemble it. That's gonna bug me. Okay, let's do this. This doesn't have to be like that. This was the defining factor for that. This can now be its own thing, which leaves this guy defined, which we don't need to be. That doesn't need to be defined anymore. And this can come at an angle like this. That, and hopefully nothing broke. Okay, and we'll go back into the knuckle, and hopefully nothing broke. And we did broke it. Well, grab this face instead. Then we'll come back into this part. Actually, we'll do it in context of this part. We're gonna add, is it from the top line? No, it's not. So a plane that is eccentric with the center of that. Sketch on that plane that will have no external references, but we will add a nice cool little yo, what are you doing? We're gonna add a little locator bump. And we definitely want this at 45 degrees. We want this to be just out of the way of that diameter by a hair, so I'll make it 1.325, which is not good. 325, which I think is exact, so we'll go 0.35. That's a made-up number. That's not a real dimension. 0.025. We'll add an axis for it to rotate about. We will make it the same length as this other part so that it is fully defined. We'll make it a construction line. We'll define it to the origin, confine it to the origin, I guess. Yo, why not? Okay, we'll use that sketch. We'll do a revolve, and with that, now, when we do a cross-sectional view, we get, oh shoot, that hole needs to be much less. Okay, that makes sense. So this diameter is 0.33. The radius is 33. What is the diameter? This is our 6.5, which is our 6.25. So if we make the hole in this .6875, then when we hop into our little revolvey guy here, instead of it being arbitrarily dimensioned, we can actually snag that same radius now, or whatever, the same diameter. We'll make it pierce that dimension, and that's printable. We can print that. And this is not used for any type of rotational movement. It's strictly used as an alignment tool while you're assembling it, which was the entire point of the having the other part stick into this part. So with that done, let's just do this within the revolve itself. We're going to come up to the plane here. We're going to mirror this. Dunzo Ferrari. Enchiladas are name. Boom. Okay, because otherwise this whole plate here is just held by those screws, and I don't like that. I don't like that idea. So now it actually has some like mechanical interface with the with the part here. So like I said, if you take a cross section at this guy's midplane, you're gonna see that the knuckle part itself, oops, I need to make those two merge. It has a face to sit on, you know? Yeah, so that's good. And then we can print the bushing without any support. So let's show this. Boom. Edit that. Boom. Yo, what's going on here? It doesn't want to let me. You know what? This and this and this. Okay. Beautiful, gorgeous. So let's actually hop into Bamboo here. I'm loading Bamboo, but I want to start this part printing because we need to do some interface testing, and then I think I gotta call it a night. I'm about 30 minutes over. By the time I'm done with this, it'll be about another 30 minutes. So let's do some test print. Not this part. This part for sure. So we're going to save it as a 3MF. And let me get Bamboo sized up here for lay. parts are really small. Okay. We're gonna do 2 standards, probably fine. Let's just see what it looks like real quick. I want to see how much detail it's picking up on those nuts. Okay, so there's like, there's not a lot going on there. They could come out looking a little funky. We'll have to deal with that. Okay, if I shrink bamboo, does it shrink? Yes. So we need to, we're gonna print that part for sure, and I want to print the interface. The drive interface part. Might as well cut this groove in it real quick for this motor. So we'll start a sketch on that. Where's our motor shaft? Oh, there it is. We've started a sketch, then we can convert this and this. We come in here, do an offset of 0.01. I think that's what the other one was. We convert these two to construction geometries. We extrude cut this to a depth of more than the shaft. That looks pretty good. We're interfacing with only the bushing, right? And then our arm thingy. And none of these are the final parts, so we don't need to add too much more detail. But it would be prudent to, you know what? Let's add some flat spots on this. We're gonna add some flat spots because, again, instead of the hardware taking the load, the parts will have their own, they'll be their own responsible parties. So do we like 4, or does 5 look cooler? Or does 6 look cooler? I think 6 looks cooler. And then we go this and do that wrong. Beautiful. Then we can actually, I'm going to fill out these corners. I know I said we're not going to add more detail to this, but if I'm going to print it, I'm going to print it. Nice. Okay, sweet. So that goes in like that. And on this one, we'll hole. Every third one. We want 3 bolts. What type of hole did I make? I did 1.5. But the clearance. Oops, where's my bolt? This first part is a clearance. We're doing this wrong. We want a hole wizard on this side. I'm going to put the position. We're going to get that going right there, but we're going to come to the back. And with the midpoint of this, I'm going to go there, hit that. That looks good to me. We're going to skip these 2 instances because that's dumb. We're going to go back to the type of bolt hole. We are going to use a, what are these called? Counter bore. It is very tiny. The shaft diameter we want for a clearance is 0.7. 5. Oops, that's not in millimeters. That's going to be 2 millimeters would be really loose, but we'll do 2. The head diameter is 3.5, and the head height is 2. And that looks okay, except it's pretty shallow, but I think we'll be alright. Then we're gonna circular pattern this 3 times. And in the future we will add these as fake features. But this guy. So we can go ahead and print this part. And we'll come back tomorrow and we'll add those same features to this. Oops. I took away its concentricity reference. We'll give it back. There you go. You happy now? Okay, so then we need this part to be a 3MF. You know what? I'm gonna add a little chamfer around this edge. Where's the outside of this clean? Let's look at this one more time. So we've got our plug here that's going to bolt to the plug, bolts to the arm, and it rides in this channel. On the bushing, it is driven by this shaft. It is a clearance for this diameter, but it's not much of a clearance, to be honest. Not much more than what our channel is. Let's print the parts. We'll get some. It looks like we can add a chamfer to this edge, and this edge, and this edge, which I always like doing on vertical walls, so that there is more of a chance, or less of a chance, that it just snaps off with the print line. Yeah, that looks good. Okay, so we're gonna. You know what I learned when I made the parts for the Formula One car was if I add a column, I don't want a hole wizard, I want an extrude cut. Here, that is like just roughly just a little bit smaller than the other feature, then I will get 3D print walls all the way up to the bottom of this, so that this isn't twisting against just infill. And so that would be 5.2 millimeters times 5 layers. Okay, perfect. So now we'll save this as a 3MF. We'll throw it in Bamboo Labs. And both of these parts print without support. One will go in the other, and they should spin like a slip ring, but with no no electronics. So we're gonna pop back into SolidWorks one more time before we start printing stuff, because I think I'm ready to print the tower housing top part. So if I'm looking at this, and let's see if this happens. Bodies to delete. Boom. Is there any reason not to print this? So what I'm looking at is that, oh, what is this all about? Why do I have like two, what is going on there? I do not know what's going on there. Is that an extrusion? What happened? I'm not sure, but I don't think I have a reason not to print this. So I think I'm going to add a couple fillets here to not just make it prettier, but make some of these transitions a little less harsh. Except, is it better if it is? I don't know. How's that? Is that looking good? And this one's probably gonna break stuff. Maybe not. I don't know if the less harsh transitions are completely necessary, but I don't like the sharp corners, especially in 3D printing. I think it makes parts weak. The fillets do add a structural element to that, so I will argue that totally made up fact till the day I die because it's prettier. Okay. And that looks pretty good, so except I don't know what's going on here. Are these separate bodies? 45 millimeter. What happened with that? What is that? What's going on? Oh shoot, you're not looking at songs. Diameter hole. And then when I delete the body, okay, so let's just do a combine. Where's combine? I guess there's not separate bodies. That's just tripping me up. What the heck is that? Do not know. Well, let's see if it comes out in the slicer. So we'll save it as a 3 muff. And we will pop back over into Bamboo. I think we called it the As Knuckle. Okay, no we didn't. What did we call this? Oh, I saved it in the wrong place. This part will get support. I could not come up with a way to not have support on it. So that's just the way it be. Wait, where are the holes? Oh, only one side. Whoopies. We'll hop back over to SolidWorks for just a second. From this side and propagate them to the other side. Looks good to me. Why couldn't these legs go all the way down to the bottom? I totally forgot about that. Why couldn't they go down to the bottom? Why do we need support? Because that motor is in the way. Makes sense to me. Okay. Oh shoot, I did it again. Oh my gosh, it's after midnight. I'm gonna die. At least I'm actually tired. I have had such a hard time sleeping. When I first got my eye surgery, it was not good. I was hurting. I was in a lot of pain. Every time I opened her, my eyes tried to blink. And so I just did everything I could to not have to open my eyes or blink. And that involved sleeping like 15 to 20 hours a day. And that totally wrecked my sleep schedule. Now that I can blink, I'm not in a good circadian rhythm. I think we should make this distance here bigger. Because I don't like the way that counter bore is close to the edge. And a lot of things should just update. Oh shoot. Why? Oh. Because of this cut. That looks fine. We're gonna redo our 3MF of this. We can close this now. We can save and close this. We can close this. We can close SolidWorks. We can open up Bamboo. We can insert our drive interface. We can delete that one. We'll throw this down on its face here. We will throw this knuckle in here. Boom, boom, looking good. We need to put it on this face. Move some things around. This one needs support. We will enable the supports. Default tree. And slice. And if we take a look at it, the support material is doing everything it can. See, this is why I didn't want a bearing surface here, because the circle's not actually going to be round, right? Look at that, it's not a round circle. But these are round circles, and these are going to be what interface with each other, so should be good to go. I don't see a reason not to print this right now. So we'll pop over here. We will send it. And with that, I gotta call it a night. But thank you for watching. How long did we go for? Almost 2 hours. Not bad. So my name is Zach. This is Snachary. We do crazy electronics projects pretty much all the time. A lot of 3D printing, a lot of CAD work, and then some stuff in the shop. So I submitted this project to Opensauce 2025 as kind of an incomplete idea. They reached out and said they were interested in it, but they wanted to see some more progress. So I'm trying to finish it up in the next 2 days so that I can send it to them for approval. And if that happens, then I guess I will be trying to plan a trip to San Francisco. So I appreciate you tuning in. We are just about to sign off for today. Let's take one look at our parts that we're printing for today. We're printing the azimuth tower, the bushing that interfaces with the side of that and gives us a round surface for the arm lift to press into and pivot will fill this channel with grease, and when the antenna is commanded to elevate, it should have a nice pivoting moment. So once again, thank you for tuning in. I am going to have to call it a night. I appreciate your support. Have a good one.